So here we are going to move on this lecture. So here you can see uh, we will see TypedDict and data class in LangGraph. Okay. So here a state schema with data class. So when we define LangGraph state graph, okay, we use state schema. Okay. So state schema represent the structure and type of data. It represents structure and type of data that graph will work with. Okay, and all node in the graph communicate using this schema. Okay, all node communicate using this schema in the graph. Okay, so LangChain allow flexibility in defining the state schema using TypedDict data class or even Pydantic. LangGraph allow flexibility in defining the state schema using TypedDict data class or even Pydantic. Here we can see TypedDict and data class using a beverage selection workflow. So here we can use the TypedDict class for Python typing module. It allows to specify key and their corresponding values. Okay, but note that these are the type hint. They can use a static type checker like MyPy or IDE catch the potential type related error before the code is run, but they are not enforced at the runtime. So why we use TypedDict and data class in LangGraph? Okay, so LangGraph pass state between nodes. Okay, typedict and data class define the state schema, structure and type of data. So here typedict dictionary style with the type hint. Okay, so this is the dictionary style, like we have key and value like this and this one, live weighted and listen friendly. Okay, runtime not enforce wrong type still run. Okay, so like graph, for example, graph.invo name should be in string, but it also pass in integer. Okay, so it work even if it is integer. Okay, so this is not right. Okay, I think this will not run. Okay, it should be give us error, but it work. Okay, so this is the type dict, and this is the data class object style state. Type says support default runtime validation must pass correct types. Okay, so it must pass correct type, like graph.invoke data class. Okay, with the help of this, we don't use any kind of dict like this. We use state data class instant here, and name equals to alias. Okay, then it will work. Okay, benefit and LangGraph predict state structure, safe logical conditional logic, easier debugging and visualization, ID, autocomplete and type checking. It will check type. Okay, so here you can see you can pass any dictionary at runtime like this name 123. Okay, but name should be in a string, not an integer. So no runtime check. It will not check in runtime. So you must pass an instant of the data class like this one state name alias. Okay, we need to pass instant here of the instant of data class. Yeah, so if you pass a disk, it will raise a error. So here one only type hint not enforced at runtime, and data class enforce structured field name, but Python doesn't strictly enforce type at runtime unless you add the validation. Okay, so here you can see TypedDict more flexible for quick and experiments. Data class safer, structure better for large complex graph, but strict, stricter. Okay, here you can see this is the example of, I mean graph.invo. This took one TypedDict and it worked. There is no error, and if you write like this indict, then data class give you error type error, and if you write and call the instant of data class here, then it will work. Okay, so here I'm going to write code for TypedDict. Okay, okay, here, so I have code there. So I need to import things like this. Okay, so here from typing extension import TypedDict. Okay, TypedDict, it will like TypedDict means this one. Okay, dictionary style. Okay, state with type hint. Okay, so it is used for type hinting, and it will give you a dictionary with key and value pair. Okay, typing import literal. Okay, this is also type hint. Okay, like if you decide any values, like if you have any literals in any function, like you have some fruits name. Okay, then you can't change it at runtime, otherwise it will give you error. And here you can see random, for any random things. And here from python display import image. Okay, that we can display image. And here from langgraph dot graph import state graph and start and end. These are the super node, and this is the for state graphs for graph. Okay, so after importing these things, I need to define a schema. So here you can see I need to copy it and paste it here. Okay, define the state schema. This is the class of TypedDict. Okay, here inside I need to pass TypedDict for type hinting. Okay, so name should be in string, but it took some integer value also. And this is the beverage literal. Literal also like a type hint, special typing form to define literal type aka value type. This can be used to indicate to type checker that corresponding variable of or function parameter has a value equivalent to the provided literal or one of the literal. Okay, like this is like if you have t and copy, then you can't change. This is the fixed type of variables. You can't change it at runtime. Like if you pass juice at runtime, then it will raise the error. Okay, and after this I need to define nodes. So here I need to copy it and paste it here. Node. Okay, so node function choose averages. Okay, so here we already passed state. I already show you in previous lecture. Okay, so here and state type dict. Okay, so here you can see the state schema represent the structure and type of the data that graph will work. Okay, when define lang graph state graph, we use state schema. Okay, so this is the state schema inside all node in the graph communicate using this schema. Okay, so allow flexible in defining the state schema. Okay, so here we are going to define state schema using TypedDict, or even as of now we are going to define only TypedDict. This is the state, and here we are going to print choose beverage not node has been called. Okay, and here I'm going to return name of this state and want of beverages. Okay, this is function. This is a node function for t. Okay, like and this is the type dict and this is the state, and here t node has been called, and this is the parent string. Now return name string. In string need to return name and choose t and beverage and t. Here you can see copy, this function for coffee, and print statement coffee node has been called. Okay, and this is we are going to return here name. Okay, now after this define function fixed. Okay, so here define function fixed. Okay, so decide beverages. Okay, here we can decide beverages. So here these are the literal t and copies. Okay, and this is the state and this is the type dict. Okay, make sure we return the exact node name that exit in the graph. Make sure we return the exact node name that exit in the graph. Okay, so choice equals to t if random dot random is less than 0.5. Okay, else copy and print decision going to choice and return choice. Okay, and after this build the graph. Okay, now we are going to build graph. Okay, here this is the builder variable, and this is the instant of state graph, and here this is the TypedDict. Okay, you can also see here. Mm, TypedDict define the structure and data type. Okay, so here this is the TypedDict, and here these are the nodes. Builder dot add nodes, choose beverages. Okay, here this one, choose beverages, this function. Okay, and I mean node for choose beverage function. Okay, this is also node for tea function. This is a node for coffee function. And so these are the node for these function, these three function. Okay, and now define the ages. Okay, so here builder dot age start. Okay, these are the super nodes. Okay, or here we are going to start from beverages, so that's why we need to put here beverages. Okay, builder dot add conditional. Okay, so we are going to apply conditional ages here, because we need to choose beverages and decide the beverages. Okay, so here we can choose a tea or coffee. So here map to tea node and map to coffee node. Okay, and after that build the edges for t. And if you want to t, then like if you want to, if your choice want to take a t, then you took t and if you want to take coffee, then take coffee and it will end. Okay, and after this I need to compile and display my graph, so that's why I use graph equals to builder dot compile. Okay, so here this is for displaying the graph in the image form, and the image is marmot png. Okay, so graph dot get graph. So here I need to run this, so you can see start. Okay, choose beverages. Okay, so if you want to coffee, then you can go there and if you want tea, you can go there and it will end here. Okay, so this is the graph. And after this I need to invoke the graph. Okay, so here control C, invoke the graph. Here print first invocation. Okay, so result equals to graph dot invoke name equals to alias. Okay, so final result, so I need to copy it. Control X, here I'm going to paste in upper cell. Okay, so here you can see first invocation choose beverages node has been called. Okay, okay, so result graph dot invoke name alias. Okay, decision going to T nodes and the node has been called. So final result name alias want a beverage, choose T and beverage T. Okay, so you can see here this one, this one. Okay, here I'm going to copy it, and you can check with it. Okay, I have deleted after it. Okay, so here I already passed name. Okay, so name is here this one. Okay, in string state this is instant, and name is the alias. Okay, alias want a beverage, choose tea, this one, and beverage is tea. Okay, and after that, after this I want to delete it, and we can see here. So this is the graph.involve name 123 and result. Okay, but we already defined it is in string. Okay, but uh, it will not throw any error. Okay, you can see here we already defined name should be in string, but it will give name in but I mean it doesn't give any error from this. Okay, so name in integer. So how I mean this is not correct. Okay, so we want name in string, so it should be in string. Okay, so final result name 123 want a beverage, choose tea and beverage tea. Okay, so so guys, this is a what TypedDict. Okay, TypedDict uh, in a LangGraph. Okay, now I'm going to move in data class. Okay, so here you can see a Python class for structured data, primarily storing attributes. Okay, so here I also have code for data classes. Okay, so here I need to import these things. Okay, from data classes import data class, from typing import literal, for type hinting this is for random things. Okay, so from ipython dot display import image and display, from langgraph dot graph import state graph start and end. Okay, and after this um, I need to define this one. um, okay, um, here you can see this is a data class. So here this is the data class, classes data class state. Okay, so name should be in string and literal tea and coffee, make beverage of optional. So here after this I need to define nodes. So here I need to copy it and paste it here. Okay, so this is the function for choose beverages. Okay, okay, this is same as before, and this is the function for tea. These are the node function. Okay, and this is the node function for coffee. If you want to select coffee, then this will answer. Okay, after this we need to okay, here you can see decide the beverages. Okay, here choice equals to t if you like t, like choice equals to t, then if random dot random is less than 0.5 else for. Okay, so print and return choice, and after this I need to build graph. So here um, here this is the state graph. Sorry, this is the instant of graph. These are the nodes for choose beverages, tea and coffee. Okay, and here we can see these are the edges for this is the for choose beverages. Okay, and you start node super nodes. Okay, and this is the build dot age conditional edge. Here we are going to apply conditional edges, so we can choose beverages or decide beverages. Okay, so tea, you can take tea, then take tea, and it will end. Okay, and if you want to copy start, if you want to copy, then it will start, take copy and end. Okay, so here we mapped t with t and copy with key copy. Okay, so builder dot age, so these are the age for t and copy and end, t and copy end. Okay, so graph.builder.compare, here we can display our graph here. So start, choose averages, choose copy and t, and here you can see and you can go this way and you can also go on this way. Start, choose averages, took copy and end. Start, choose averages, took t and end. Okay. Mm. Now okay, I need to invoke it. Okay, so graph invoke data class, so we need to use the proper initiate state. Okay, invoke with proper initiate state with data class. This one we need to use this class here, data class, data class, data class, data class, this data class state. Okay, okay, but in TypedDict we don't have anything like this. Okay, now equals to ls and average equals to none. Okay, so alias one tab averages to t and things like that. Alternatively, you can invoke with dictionary instead of data class system. Okay, so I think guys, I have completed data class and typed it, and I hope you like my video. Okay, bye bye, take care.